The radio I put together was like a 50% fail. It seems to be working, it turns on, but there's no sound. So I decided that I leave troubleshooting for last. First, I want to go through all the projects. I mean, I have this. What this is serious. The others are not as serious because they are basically uh, just circuit boards already soldered and everything, and they just have to go into some gadget device, speakers, whatever. So yeah, this is a digital clock. And sorry for the lighting. I'm using an alternative light because the phone's LED flash turns off after 20 minutes. So I can't use that because this will be surely a really long video looking at all the components. Yeah. Oh, so let's get started by looking at the stuff and trying to figure out which stuff goes where. There's a PC board, logic board, whatever. Uh, so there's a quartz that you need for everything that needs timing. This will give the rhythm for the whole thing. Two resistors, I don't know what value. We'll see that soon enough. This is probably transistor S8550 0331. Okay, this is the same, I think. Come on, can you focus? Yeah, 331. Oh, it's a D, it's not a zero. It's a D. Okay. Right, it's a D. And they are identical. Yeah, push button. I like this kind. It has a smaller tip. Yeah, diode, capacitor. This is the chip, which should include the software. Yeah, the programming. I mean, it's basically a microcontroller. So yeah, that's what we'll call it, microcontroller. But you probably can't reprogram it because it's not it doesn't have a flash memory or anything. So this, you solder this thing on the circuit board, and then you put this in. So the chip is, oh, it has writing on the back too, not only the front. So it's IMEL, Atmel 0932 T89 C2051 dash 24 PU. So, and in the back, I don't think this is very important, but 9F0 647. I bet think that's an I 9654F. One China Wu 932 and E3. Whatever. I don't think it matters. This should be pretty generic because this is standard application when you're building a stupid digital clock. That's nothing special. So this is for the power, a connector where you can tie down two wires. Let's see, this should be, oh, capacitor. D331, the same transistor. Or maybe it's not a transistor and I'm being stupid, but it has 3 legs, so that's why I call it a transistor. But sometimes it's a chip. It may have more elaborate circuitry inside. So this is identical to the other 3. This is something else. Let me see if I can maybe even zoom in. So this one is WS 78L05 2201 SD. Okay, maybe it's a transistor, maybe it's not. This is identical to the others. 331 capacitor. Oh boy, something. Oh, this is bent and it was inside the paper. It was pushed inside the paper. So these are soldering. You have to solder it by these legs. So that's one minus for this kit. Oh, and this broke. Crap. I mean, it's not a big deal really, but this broke, man. That's faulty packaging. This broke. When I straightened it out, if I move it some more, this will break. And there's the breaking point right there. Oh boy. But this is not really needed, fortunately. So let's hope it's not a real problem. Maybe I won't even put it in. So here are the 3 screens. Oh, yeah, okay. Here are the model numbers, 3621 BS. Okay, we know it's BS. Yeah. 2 LEDs, which I already learned how to determine which one is the positive and the negative. So the smaller foot is the positive, the larger foot is the negative, and it's divided by a thin line. So yeah, we know that. 2 identical LEDs. What did I say this was? Oh, this is identical to the 331. One more capacitor. And let's see the board and schematics. Oh, and there are more resistors. Oh boy. Yeah. Luckily they are identical, but not the same as this one. That's interesting. Not the same as these. Okay. Well, I guess we'll find out. Oh boy, this is nice. Yeah. So it's a DF2 10109. Nice little circuit board. This looks really nice. So we have all the values here. What goes where, hopefully. Oh boy, what did I... Oh, my scissors. Okay, so... We have one button. Why do we have only one button? So here, this is for the chip, the screens, capacitors, the transistors, 6 of them. Yeah, I have 6, but one is different. This one is, yeah, this is the different transistor. I don't know. Oh, wait. We have six identical. Am I being stupid here? 1, 2, 3, 4, 5, 6. Okay. We have six identical, and here this is for the other type. Okay, some more capacitors, the power plug, the battery that we won't use now. But only one. Why is there only one button? Does this connect to the global time radio frequency, whatever that? Hmm. But yeah, I guess nowadays to set a clock you only need one button. Yeah, I even had experience with this pulse oximeter. This only has one button, and you can enter the menu, set everything with just one button. This is just not amazing, but it's nice to see that people are thinking logically. You don't need more buttons. Yeah. Okay, so this seems like a really simple project. You press the components in from this side, solder them, and yeah, let's zoom a bit out. How do you zoom out? Oh yeah, like that. And the schematics, I don't think I need the schematics. It's in Chinese, nice. But yeah, if you want to understand it, here's the drawing. So 6 volts. I wanted to power it off. Yeah, here it says 6, but here it says 5. It works with 5 volts. That's good because I want to power it from a power bank or USB charger or anything simple like that. I have a bunch of them. So yeah, hopefully it will work. And yeah, this is kind of it. On the back we have the same thing as on the circuit board. Oh, we have values here. It's not just C1. It says the value of the capacitor. Okay, that's a bit more help. But yeah, let's see. So we should start with the chip and the. Does it matter? The resistors. And hmm. Yeah, I don't think it matters. Let's just start soldering. So let's put in the chip, the chip's socket. Oh boy, this requires a lot of soldering, but yeah, I made a process that kind of works for me. So this PCB holder thing, this will hold my solder, and I rest my hand on my knee, and I move around the circuit board. That's the easiest way to solder, because this soldering iron is really really heavy, like really heavy. Yeah, here we go. The first one. Yeah. So people may ask, why do I use this two-step soldering? So first I put the solder on the tip of the soldering iron and then put it here. It's partly because it's more it's kind of lazy also, not very fast, but it gives you more control. when you're already heating up the pad and the leg of the chip, your your time constraint. You have to put the solder right there as soon as possible, and if you don't succeed, yeah, that one's a bit dodgy, but right now I'm doing kind of the opposite, or a combination what I said. I move the soldering iron around while I also rest it on my knee. So I don't know how to explain it, but I have a feel for these things. Like whatever feels right, I try it, and if it works, then it works. Yeah, one row is done. Nah, nah, nah. I think I'll have to change the tip soon. Yeah, I'm tempted to leave it like that. Some solders are not perfect, but I'm tempted to leave it like that. I don't know why. Oh boy. And they didn't bridge because there's too the distance is too big. That's nice. If they were closer, they would have bridged. But yeah, this is a really nice big PCB. It's not space constrained at all. You have space to work. So yeah, maybe somebody with experience would put in all the components at once and start soldering all the legs. But I prefer to do it this way. I don't exactly know how to explain it. But yeah, let's put in the quartz. Let me see the... Somebody already built it. So I want to look at their picture. It's crappy resolution. Wait. Let me just search for this. Because if you have a good photo, that is much more practical help than schematics. If you don't exactly know what you're doing, then oh, YouTube video, I want just an image to see how they put in. Oh, they put it in upside down. But why? Can they please explain? Oops, that's sound. We don't need sound. Yeah, nice hamburger with sauce is okay. Some fashion. Yeah, I have to sit through the ads. And here's the... I can't see, I can't tell. No, he put it in the right way. So, I don't know. This is how the second guy put it in like this. So I'll put it in like this. Yeah. Okay. that's in. So yeah, the screens, yeah, it doesn't matter in which order I put in things. But yeah, the transistors going like that. The other transistor, which is different, that goes here. Same direction, self-explanatory. 7, 8, I don't know what, 0, 5. That goes in here. Come on. Where did my skills go? I used to do this when I was a kid. I used to do desoldering and soldering too. So yeah, is that how tall it should be? Like that? Yeah, kind of like that. That's how the guy put it in the video. Let me just make room by bending the legs. So when you're soldering, you can also have the solder in your one hand and soldering iron in the other, and place them both at once there. But that's a bit harder, I think. So yeah, this is in exactly like in the picture. So yeah, that's how I need to do the others, which are, yeah, the number on top. That's what counts. That's shown on the circuit board. Like that. So let's put in all of them. Okay. Like that. 8550. 8550. Come on in. Like that. 8550. So these are controlling the LED displays. Almost certainly. Even if I don't know anything about this circuit, that's what I know for sure. These are switching the power, most likely. Tell me in the comments if I'm wrong. So this is also that type. I'm trying to double check everything. Come on, go in. Like that. And this one also 5, 5, whatever. Man, there's a little fly here. That's flying into my eye from time to time. And I got him. Okay, never mind. It flew too close to the cuckoo's nest. Okay, so how does this look? Okay, it's alright. Like that. And let's start soldering them in. Yeah, oh, one more, sorry. Man, this soldering is kind of boring. Is that what you call it? Boring? Yep, boring. But yeah, I wanted to try doing this. Try it if I enjoy it. But now maybe I still enjoy it kinda, but not really. If I were not making a video, I wouldn't enjoy it, I think. If I didn't get to share the experience. Man, I shaped the tip really well last time. I can reach everywhere. This is really good. This is a good tip. Good tip about a tip. To bend it so you can reach between the legs. Yeah, that didn't come out right. To reach between the legs. You know what I mean. Man, how many more? And I try not to breathe because, you know, fumes. I have an air filter running, but it's kind of further away from my desk. And also, a fan is blowing through the room from one end to the other. So, this shouldn't be a problem. It's a big problem only if you're in a closed room. And then the particulates and gases get accumulated. Then you die. And your cat dies. And everybody who comes in contact with you dies. So, don't do that. Use an air filter. The HEPA filter, I think. That's the one that filters even the smallest particles. Because smoke is really small particles. When you're seeing the smoke coming from the soldering iron, that's small particles. And the HEPA filter that filters really small particles, that will filter everything out, hopefully, if the companies are not lying to us. So, the button. Can it only go in one way? Or it can go in like this? Yeah, the legs are a bit bent. That doesn't help.
There is nothing to repeat.
Alexa just said, "Sorry, there is nothing to repeat." Isn't that funny? So, this is how the legs go in. They should go in, but they don't. What's going on with this button? I have spares, but yeah, let me check the radio. Yep, that's how it makes contact. The bottom two get connected to the top two. That's interesting. I never knew that. I thought it was the other way. But then again, I didn't work much with these switches because these are like low durability. I think I read 20,000 presses for one before failure. So these are not the best. For a mechanical keyboard, that's the top. Those are the best switches. Those last for 50 million presses, and this only 20,000. So the difference is quite huge. Yeah. So does this have a positive and negative? Nope. No, it says 5 to 12 volts. Okay, so I can power it off a USB. I'll just make a. I mean, make. I will cut a USB cable. Man, I love it how strong this connector is. But I guess that's what they use everywhere. As if the clock would use like 20 amps of power. So, large plug, it's more solder. Okay, I think it's good. Oh boy, more components here. So I almost threw away the bag. Okay. Yeah. So, how to tell which resistor is which? And I didn't search for my multimeter yet. I don't know where it is. I really need the multimeter because I would like to measure the resistors. Where is? I'll be right back. Maybe 1 minute. Hopefully less. Yay, I found it. It didn't take that long. Great. I found my multimeter. So, I can set this to um, how much? 1.4K. So that's 4.7. What am I saying? It's not that late. Come on. So set it to 20K and measure. We should have 6 of these. So these. Come on. 0.46. These are these then. The 470s. So these are the 470s, and these should give integer numbers. Yeah, 4.6. Yeah, these are for these right here. There are only, yeah, there are 6. Okay, no problem. It's 6. That's cool. Let me try a trick. Let's put them in like this. So 4.6. Oh, I can't do that. That's too barbaric. To put them all in at once. Yeah, that was a bad idea. Let's just put them in like normal people. So these are the 4 point... Man, I get distracted. Why do I get distracted? So the 4.6. That should come here. 4.6, okay. These are the ones I'm looking for. Man, these are kind of brittle. The legs and everything, I don't know why. They feel really brittle. Oh, let's put them in the same orientation. How did they put it? Yeah, like this exactly. I looked at the image on my computer that I found on where did I find it? Oh, in a YouTube video. Yeah. It's nice when you see it. Then you're just like a monkey. You mimic what they did, and if it looks like that, it should work. Oh, the other way around. Let's be mindful of aesthetics. But yeah, these components don't look that nice. The paint is smeared here. It's They didn't let it dry or something. So they didn't care how it looks. Oh well. Yeah, two more. The other way around with yellow on top. Okay. Like that. And this one also the other way around, yellow on top. Okay. Now to solder in 12 legs. Oh boy. That would be interesting. Let me just get into position. How do I do this? Oh boy. Bend it like this and reach in like this. Okay, let's try it. Let's get the solder closer and reach in like this. And it will hurt my hand because I'm holding the resistor in the back. I mean in the front. This is the back. Yeah, I think it's working. Even the smoke is going away in the other direction. That's good. So yeah, I think for beginners this will be a better choice, to have a simple soldering iron. Because the other one is just too much. You leave it. Yeah, this has that problem too. So I don't know. Choose whatever you feel like using. But this is just my experience that I work better with this. If I keep the solder right here, and it's really close to the PCB, so I have to, oh, the tip is burning down. Yeah, I have to replace it, but I made replacements yesterday, so I just take it out, unscrew these two screws. It's hot, so I have to be careful. I remove the tip, I put in a new one, like this, into the two holes, like that. It's in, tighten the screws, and it's done. So I think I could do it with a plug, but I have to find something heat resistant, because these plugs, for example, these ones, technically you can just shove in a conductor, a piece of wire, and it will hold it even without uh, mm, twisting these screws, even without screwing it down. So I could use something like that for the soldering iron. I'm not sure yet. But yeah, let's bend the tip. Let's see if it moves. No? Okay. It's slightly different shape, but I can use it the same. It takes like 2 minutes to get used to it. So let's get some solder. Oh, sorry. And yeah, good as new. Almost. I still have to get used to the shape. It it behaves slightly differently when it's new. So when it's new, the wire is thicker. I mean, it has the original thickness, but as you use it, it gets thinner and thinner until it burns out. So that's something to keep in mind. And yeah, let's just get these legs off because this is a mess. This is annoying. These transistors too. I'm just using some $50 scissors to get everything off. Come on. I'm being brutal here. Barbarian. I'm ruining the scissors. Oh boy. So I have to make. I'll make a cutting tool out of scissors. I just have to shorten the beak. Okay, I did a lot of damage here, man. I wasn't thinking. And these ends are sharp. Oh boy. This was a bad idea. But that's why I do it, so you can learn. And this will probably break off. Yeah, don't do this. This is bad. This was a bad idea. You have to use the proper tool. Yeah. I think it will be fine. I don't see any damage, any serious damage. Everything is still connected, but yeah, don't do that. Don't be stupid like me. Okay, so what else do we destroy? Let's measure these other. Oh, I already measured these. So these are the other resistors for the. Ugh. Okay, maybe it's easier to cut the legs when they are still out. Should I try that? So these are the 460s. Yeah, I said that right. 460s. Or the other way around. Like this. I don't want to cut it off. I don't know why. I want to cut them off at the end when they are already soldered. This makes no sense. I don't know why I want to do it like that. But right now I think I can't think. I can't think ahead. What could happen if I chop off all the legs off before inserting them? I mean, probably it's harder to put them in, but otherwise, I don't know. Wait, I mixed up some of them. This. Oh crap. Crap. I'll have to measure all of them. So. Wait, and the multimeter just turned off. So. This is for this. I mean, it's 4.5. 4.5. What am I? Oh, crap. Two are here. These are the other ones that are not standard. I mean, these are tens. Okay. So the tens have a different spot. but I should have 4 more of these. And I have 5. Why? Why? So the 10s go here. And these are all 4s. 4.5. 4.6. What? 4.6. 4.5. 4.6. What? I mean 450. These are 450 and these are 460. Why? Am I missing a resistor here? What happened? Nope. Then I have a spare? R3. Oh. This is a 10, this is a 10. And 6 of each. Oh no, there's 7. What? There's 7, but then one is still remaining. Oh yeah, one is here. Oh, everything is fine. Okay. So one goes up here. I don't know why they did it like this. So yellow stripe on top. Like that. Yellow stripe on top. And we'll just forget what's on the back, where I butchered all the legs. I think I leave them longer. If I leave the legs longer, then it's not a problem. Then the scissors will cut them nicely. Like that. And like that. Man, this is $7 and $70 of labor that you do. Okay, let's get some more solder from the holder, like that. And let's try to put them in, I mean solder them in. Okay, so I'm holding them, and yeah, first this one on the bottom. Okay, okay, I don't have to hold that, I'm only holding the top ones. Yeah. I mean, it takes a skill to release the button exactly when it's done. You can leave it a bit longer, like a few milliseconds longer. This is not good. I messed this one up. Okay, now it's good. It has too much solder, but at least it's good. Yeah, maybe do it like this. Yeah, the new tip is behaving a bit strange. When I pull it out, I mean pull it away, it makes a scratching sound. But that's I don't think it's a problem. It's just a different feel. Okay, let's cut these ones off. Let's cut all of them if we can. Like that. Hopefully I'm not short-circuiting anything, because these are jumping all around. But yeah. Oh, and these two. Man, I'm butchering this. But I think I will make a cover for it, like semi-transparent. I have a light diffuser material on which it will show up kind of weird, but you'll only see the display. My shitty job won't show up. Oh, this is not good. Or is it? Do you see? Right there? I can't see it. Maybe it's good, maybe it's bad. That's good. That's good. I don't know. Better safe than sorry. But I don't think I can ruin this. So, in the worst case, some parts of the display won't work, or something like that. Man, something dark is reflecting in the solder. That's throwing me off. I think there's solder missing, when in fact it's just a black shadow. I mean a black reflection. Okay, 52 minutes, 53, and we're halfway done. We still need all these components. Okay, screens. They only have 8 legs. 10. Okay. At least they are identical. And what? 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 Look, do you see a problem here? The dots are there. I mean the 8 figure, and the dot is there. And on the screen the dot is here. How do you twist it to make the dots go there? That's funny. That's just a printing error. This must go in like this. Everybody else mounted it like this. Like that. But it's funny. When you're a noob like me and you face an impossible problem. Then you go online and try to search for a display that is exactly like this. That the dot is before the number. And you can't find it, then you panic, try returning the product. They won't give back your money because it says so on the warranty. That once you start soldering, it's over. So, yeah. So let's solder in the screens. Oh boy, a lot, a lot of soldering. So let's pay attention. Solder on the leg. Crap. I need more solder and more power. Okay, I think that did it. So let's solder one leg of each screen so I won't have any problems. So what I feel I have to do now with the soldering iron is to press against, not very hard, but press against the pad and the leg to get a good yeah, that was perfect. Perfect demonstration. Oh boy, and this went into my finger. I was holding it so tight. Okay. Oh boy, my back is killing me. And I'm only halfway through and 1 hour. Man. Let's get some more solder here. And continue. Oh, a leg came here. So, press. Okay. Press. Okay. Press. Okay. Press. Okay. So when the solder flows on the leg and on the pad, then you know it's okay. I keep seeing the black shadow again. I mean black reflection. It's good if it's repetitive, then you get a feel for it and continue. Oh boy. So this soldering iron is 56 watts. That's why it can heat up so fast. My father made it like 40 years ago, or even 50, and it still works. It has no moving parts. The only moving part is when it falls on the ground and breaks something, because it's so tough that it doesn't break. It breaks your leg or something. 1 kilogram of steel. So are the screens straight? Yeah, mostly straight. Okay. Now let's continue. Let's go diagonally. Wait, the solder remained there. Okay. So I'm wondering how they fix how you set the time. Does it receive that signal, or you have to set it with that one button? What's interesting is that my grandfather, now my sister has it, my grandfather had a wristwatch that was half mechanical, half electronic. So it had moving parts, but it had that feature that you just pressed it and it would spin into the right position. It would get the radio signal with the exact time and spin in the right position and stay there. And well, it's okay. I did it. I mean, it wouldn't output anything. It just I just imagined that it said, okay, time set, sir. Internet time updated on a mechanical wristwatch. That's interesting. So the LEDs go there. Do I have 1, 2, 3, 4? 4 LEDs, okay, that's all we need. And yeah, let's put them in with the positive on the right side, like this. It's also the longer pin. Okay, this is an exact fit. That's what I like. I don't have to bend the... So the positive is the longer one that goes in there. Like that. Don't fall down. Don't fall down on me. Wait. Here the positive is on the other side. What? Does that make sense? And here? The positive is there. So positive... Wait. Positive, positive. And as you can see, the positive is there on this side. If it can focus, look. And the other one has the positive on the right side. I don't know why. Is the circuitry twisted here? No, wait. Oh, I'm being stupid. The positive and negative can be tied together. That's not a problem. Even here, the positive and negative are connected. So that's how the chip controls it. Okay, that's not a problem. That's good then. That's the way the board was designed. Okay. I am beginning to understand some of this electronics. Crap. So let's see what's the thermal characteristic of these LEDs. Yeah, about the same as the others. The screen was harder to solder, but these, fine. I think I'll have to buy new solder. After these projects, I just used a lot. Actually, why didn't they include solder in the kit? Huh? They wanted to use my solder? I thought it said it has everything included. Nope. It didn't have everything included. They didn't include solder. So it's false advertising. Yeah, I think I burned through this tip too. Oh boy. But I don't think it's a really... Oops. What's going on there? Only half of it got heated. Why? Yeah, okay. Let's cut them off. Leave them longer to have a nice clean cut. With the scissors. I leave the screen legs as they are. They are not that long. So, is this almost ready? Does it look ready? It almost is. Oh boy. Few second break. I'm also at 1 hour 5 minutes. Oh boy. It's still ticking. So yeah, like that. Let's move the mouse a bit so it won't so the screen won't time out. Let's get some things out of the way. That's the radio. I just got it out of the way. And oh boy. So a big capacitor comes here with the negative on the left side, like this. Is this the one? 220 microfarads, 25 volts. Yeah. Two smaller ones with the 10 microfarad. Yeah, it's 10 microfarad, 50 volts. Those come here, the positive on that side, negative on that side. Like that. Is this also a 10 microfarad? Where is it? 10 microfarad, okay. Positive, negative. And where does the other one? There's one more. Oh, here. Also a 10 microfarad. Small farad, microfarad. That's in German it means really small bicycle. Yeah, 10. Okay. And the positive goes on top, negative on the bottom. Okay. Man, it's almost done. I almost built a clock in an hour. Building a clock in an hour. That should be the title. Oh, that's solder. Okay, man, this is some job. But yeah, I wanted to do these for YouTube, but also for the exercise because I want to do these things more. Maybe some robotics with Arduino and stuff. So yeah, I wasn't willing to jump into that directly. I didn't feel like I could. But now, after a bit of soldering and figuring things out with two more projects, hopefully I will have the confidence and the skills to do it. And get into programming Arduino and I mean, yeah, I don't know why I didn't get into that. I'm being stupid. I have the components, everything. I have everything, and I could do even a 3D printer. I had a plan, a basic concept of how to make a 3D printer just with a hot glue gun and excuse me, tiny stepper motors. It would be really easy to do. But yeah, first I need to solder. So let's see. 10K resistor. These are 10K resistors. These come here. Let's try to put them the same direction. I mean roughly the brown line on the bottom. Or red or whatever it is. Don't sue me. I'm not a professional. I should have disclosed this fact. I'm not a professional. Don't listen to me. Anything I say will be used against yourself. Will be used against you. By you. So like that. So I like resistors and capacitors that don't have unpolarized or polar non that don't have a positive and negative. Yeah, they can go in either way. That's what I like. Then you don't make as many mistakes. So picofarad. These are even smaller bicycles in German. So there were microfarad, and these are picofarad. Really, really small bicycles. So it doesn't matter how you put them in. These must be it. This must be it. 30. It should say 30. Yeah, it says 30. Okay. Both are 30. And go in there. Like that. This is 104. This is 30. Should I leave a bit of a leg? Or it doesn't matter? They can sit right on the PCB. I leave a little leg because all the other components are sitting higher, and I don't know, it will just look nicer this way, I think. Yeah. And the other one, oh, it's harder to reach, but I'll figure it out. Because these tips can fit like that and not touch the other leg. And perfect. With a traditional soldering iron, you can't reach there. The one that has a prong, or what do you call that type of tip? Long and round, not tubular, like a full tube. What's that called? Come on, don't go there, like that. Okay. Yeah, this is amateur hour. So these are not uniformly soldered and cut. Oh boy, 1 hour 13 minutes. I'm feeling the pressure. So I still have these. Are they identical? How do I tell? Oh, I have no idea. So I have one more capacitor. That 104, yeah. That goes here. 104. And the other ones are identical. Yeah. Okay. I'm relieved. So I know how to put this thing together. And we can almost start it. If you're willing to wait around for a bit longer, I'll even turn it on. I just need a USB cable. Where can I get a USB cable? Everywhere. Everywhere. But I put them somewhere. Just to make things interesting. Oh boy. but I'll find one. So these. Okay. Now for the things with the black part. The black part where the thing is. So there, one side is marked. That's where the black goes. The black part of the. What's this? Man. Diode. It's a diode. So the black on top here. It's a Zener diode, or what do you call this? I think I remember something about Zener. But it doesn't fit right here. I make it fit like that. Like that. Yeah. So the black goes there and the black goes to the right. And we're finished. If I solder this in, we're finished. Do you understand? In just 1 hour and 20 minutes, I have finished something that a Chinese kid can do in 3 minutes. So, yeah. That's partly funny because I could have done this when I was a kid in 10 minutes. I was good at soldering at one point. So it's not the Chinese thing. It's a talented kid thing or motivated kid thing. When you're an adult, you keep putting these things off. It's your hobby? Okay, then don't do it because you're tired. That's not the way to live life. Being an adult is really stupid. You shouldn't be an adult who only goes home, cracks open a beer, and watches the football match. Oh, instead, try burning yourself with the soldering iron. That's much more fun. Okay. Wait, something is still missing. What are the cues? Oh, you have to wire these. No component, just a piece of wire. Did they provide me with pieces of wire? No, they did not. Why didn't they give me pieces of wire? Nah, I'm just kidding. I can use parts of these legs. So yeah. Did I solder everything in? Let's chop them down. Like that. Like that and like that and like this. Like that and like that and like this. Okay, 2 more here. Yeah, okay. And I have to do those jumps, 3 of them. One from here to here, one from here to here, and one from here to here. Really? Why? And this one isn't even... Oh no, I don't have to do this. Or do I? It's connected there? Yeah. Somebody did it actually under the screen. So he was smart. I'm gonna do it afterwards on the back. No problem, I think. So it should be this long. like that. This long, and with the longer part on the other side. Come on. Oh, this is magnetic. I have to be careful then. Like that. And let's make the connection. So this is called jumper wire, I think, because you jump from one part of the board to the other. And this is very primitive, so you only do this when you're too lazy to design the board properly, because you can design around these, so you don't have to do stupid things like this. So you need that and the other one too. Okay, I think I'll keep doing them on the back. Why complicate things? So like that, and it's like that long, roughly. Come on, get in. Everybody's looking. Go in. Yeah. So that's how my solution looks. Perfect, as usual. I mean, it's on the back. Nobody cares. For the other stuff I say, it's on the front. Nobody cares. It's on the front, but it will be in the dark. So nobody cares. Okay. And the other jumper. Come on. And I leave the battery tray. Oh, I can salvage a battery. Should I call it battery tray? This one. I'll salvage one from an old mainboard, a computer mainboard. I have plenty of them. Oh, even DVRs. I have defective DVRs from security systems that are defective, but the battery holder is perfectly fine. So I'll just use that. Come on, go into the hole, you. Yeah, that's what she said. And it didn't go in when she said it. Okay, like that. Hopefully it doesn't bother anything on the other side. And I'm gonna commit this atrocity. Ah! It jumped out. What? That's funny. Why did you jump out? Have you had enough? Like that. And stay there until I solder your ass. Like that. And the other part. Okay. So, time for the final checkup after 1.5 hours almost. Let's see if anything is touching. That shouldn't. So, yeah, everything that's shiny should just stay away from other shiny stuff. They look crooked, but okay. I think they are okay, I think. Mostly. They are okay. So, let's get a USB cable. Where can I get a USB cable? Oh, I only need the tip. So I have a power bank here that has a switch. I mean a toggle switch to start it. And let me get a USB cable from somewhere. Where did I put it? I had one right here on my desk. Oh boy. don't want to ruin a flash drive. Oh, here we are. Here we are. I have one. But I used it for something else and it fell. So, yeah. Here's the USB cable. It's not the cleanest, but I think it fits. Let's just solder something onto it. I mean, clean solder or whatever you call it. Let's put clean solder on it. Like that, and just put it into the thing. But first let's check the voltages, I mean the polarity. I have a USB here. I'm not gonna short circuit the power bank, I'd rather destroy my computer. Like that. Turn it on. 20 volts. And let's see which one's the positive. Oops. So the white is the positive. What? Why? Why is the white the positive? Yep, the white is the positive. I would have never guessed. That's strange. Okay, let's put the white as positive. Hmm. But which one is the positive? Oh, yeah. It's right there. I'm being blind. Or intentionally stupid or something. Oh yeah, and did anyone catch what I forgot? I forgot to do an important thing. What did I forget? Anything missing here? Should I put something there? Yeah. I just need the chip. The most important thing. Okay, I put them in. Now, hopefully they hold like that. And like that. Oh boy. This is weird. One of them is coming out. I don't have time for this. I just check for continuity to see if everything is going where it should. So the positive, I mean this is the negative, should be this one or no. This one and the other one is the positive. Okay. Right? Should we blow something up? White is the positive. Is that something correct? Does it even matter? So how do you put the chip in? That's according to the key. So there's the key, and the legs aren't perfectly straight, but I think I manhandled some of these in my life and I know how to put them in. So yeah, like that. Make sure all the legs are going in the right spots. And oh boy, it's not that simple. Yeah, they need to go closer together. How do you do that? Like that, and push Push it on one side like this, and they should be straight. Put it in. Make sure all the pins are going inside, not on the outside of the contacts. Yeah, and just push it in. Yep, it's going in. Yeah, but I'm afraid. I'm really afraid. Oh, and this came out. The one that I said that will come out just came out. So I have to do something about that. Here. This is bending outwards. I don't know why. Because I tightened it too much. Man, and this screwdriver is not appropriate. This one is. So why is it behaving so strangely? I want to put this in, and I should have soldered it directly. Now it's holding, but I don't know for how long. So let's do one more check. I want to check the power. So the positive is the white, and that scares me. So let's check a USB plug voltage. 5 volt, okay. And the schematic, when you look at it like this, the negative should be on the left side. Okay, I can check that. On continuity, and let's see if the negative, I mean the ground, is on the left. Yeah, that's what I checked. Okay, I can try it then. Everybody ready? I'm nervous. Did I solder everything properly? One more check before I blow it up. Let's get all the short-circuity things away from the board. Let's check everything. Oh, this one not touching. Okay, not touching. I think it's fine. But this keeps jumping out. I'm gonna solder it. I'm not in the mood to argue with a stupid plug. So the ground goes there. Oh boy, it's not that simple. I put away my tool, so I'm gonna solder it right here, and the other one right there, and the white is the positive, which is on top. Yes. And the other is ground. Okay, I soldered it. Shall we try it? Do we try it? It's $7. Nothing. And if I push the button, nothing. And if I push this button, nothing. Okay. Good to know. Nothing. Anything heated up? That's unpleasant. Oh boy, that's really aggravating. Maybe they gave me a bad chip, or it really needs the. It really needs the battery. I don't like this. Honestly, I don't like this. Oh boy. Why doesn't it work? Let's check the schematics. I did everything right, so yeah. So the resistors go to the screens. That's not news. And the switch just switches this pin to the ground. Yeah. I don't know what to tell you. The transistors are put in the way they should be. Yeah. These are identical, identical, identical. The 22, oh, 220 microfarad capacitor is here with the positive on that side. This weird transistor that's different, that's here. Then the diode with the proper orientation. Then the 104 capacitor soldered properly. And then these two other capacitors with the positive on the right side, 10 microfarad. Yes. This. Two resistors of 10K capacitor, positive on top, okay. The quartz there, two more capacitors here, the chip, all the resistors that I had fun soldering. Yeah, this is bothering me, the screens. I mean, this is how you should mount it, I mean install it, but why is it not starting? Why? Yeah, that's how they put in those. The yeah, with brown. And the jumper wires, the LEDs. Huh, that's a head scratcher. So let me just see if the guy turns it on. Yeah, he's soldering just like me. Puts in everything. Let's continue with the 10K resistors. Yeah. And he's turned on. Oh, he's using. Oh, he's not using 5 volts. He's using a step up circuit. Ah, okay, so 5 volts may not be enough. I need to use more. But yeah, that will be a separate video. I just built this and I try it out later.